look something like the following, where there is literally a hole in the graph. There's literally a hole in the graph. Now the question becomes, how do we know where there's a hole, where there's an asymptote, and that's where we're going next. The question so far. Okay? So, let's jump in. Number 8 in the box on the bottom of the page. And number 8 says the following. It says g of x equals x squared minus x over x squared plus x times x minus 1. And for all of these box problems, here's what you need to find. You need to find the vertical asymptotes. You need to find the horizontal asymptotes. And you need to find the holes. Those are the 3 things you need to find for all these problems with the boxes. So, how do we do this? Let's find out. Step 1, factor. Make your life easier if you can. So when you look at this, I hope everybody in here can rewrite this as the following. Any questions on how we factored that? Okay. Now, we have a much easier function to deal with, and we can start by finding the holes. Always good to start with the holes. A hole occurs whenever you cancel out a factor. Whenever you cancel out a factor, you have a hole. The hole is located at the spot where the factor equals 0. So a hole occurs whenever you cancel out a factor, and the hole is located at the spot where the factor equals 0. So here are the factors I'm going to cancel out. This goes with this, and this goes with this. So we have 2 holes here. Why? Because we canceled out 2 factors. Let me be more specific. We canceled out 2 different factors. So where's the hole located? Well, set the factor that we canceled, x minus 1, equal to 0, and solve for x. So we have a hole right here at x equals 1. Our other hole is at, set the other factor that we canceled, which was x, set that equal to 0. Well, we already solved for x, so there is our other hole, x equals 0. Any questions on identifying how many holes / where they are?
How did you get the second one?
George?
How did you get the second one, the x equals 0?
Because I canceled out the x here. So that's the factor I canceled out. And we said, make the factor equal to 0. Abel, go ahead, please.
It's always different factors, right?
Different.
So what about this one?
Well, so that's not a hole because it's not getting canceled out. We're about to deal with that here in a second. That's not a hole.
Oh,
Okay, any questions on the holes now? Okay, nothing on the holes. So now we'll proceed to the other 2, vertical asymptote and horizontal asymptote. So we want now the VA and the horizontal asymptote. And rather than using this super complicated function, let's just use the simplified version, which means these x's are gone and these x minus 1's are gone. So all I have left is on the top I have 1, and on the bottom I have x plus 1. Much easier to deal with. So let's just deal with this new g of x a little bit easier because we have removed the holes. So g of x equals 1 over x plus 1. Now, to find the vertical asymptote, this is a process that you all learned in your younger courses, which was to set the denominator equal to 0 after removing the holes. We already took care of the holes. We removed them. So now we're just going to set the denominator equal to 0. So denominator x plus 1 equals 0. Solve for x. So here is our vertical asymptote. Questions? Okay, and the last step now is to find the horizontal asymptotes. And the way we find horizontal asymptotes is we find the limit to horizontal asymptote, limit as x goes to positive infinity, and the limit as x goes to negative infinity. Because remember, the horizontal asymptote is what happens at positive infinity, what happens at negative infinity. So let's take care of that piece now. So let's do the limit as x goes to infinity of 1 over x plus 1. So now, George, you were asking earlier, do you always get infinity over infinity? Here's an example where you don't. You plug in infinity here, and you get 1 divided by infinity plus 1, which is 1 over infinity, which is 0. So what does this mean? This means we have a horizontal asymptote at y equals 0. Questions? Because horizontal asymptote is what happens at positive infinity. Now, got to check what happens at negative infinity. Might be the same, might be different. Need to check. Let's go ahead and do that. Need to check now, limit as x goes to negative infinity, 1 over x plus 1. Plug in. So we have 1 over negative infinity plus 1, 1 over negative infinity, which is 0. So we don't need to write this again. It's okay to just write it once. It's not a problem. You could just write it once. You don't need to write it again. If this had been like 3, then you would have said, okay, semicolon y equals 3. Because that would have been a second horizontal asymptote. Okay, this is the answer to problem number 8. Let me see if there are any questions, then I'm going to do number 10, which is the same as number 4, so you can scratch out one of the two. It doesn't matter to me. 10 and 4 are the same. I'm going to do 10 right now. I don't want to see any questions on 8 before I go forward. If you want to start doing 10 on your own, go for it. I mean, it's a little bit different, but the principles are the same. And again, I'll be right behind you. But I want to see if there are any questions before I move forward. Okay? If there aren't any, then I will continue. All right. Alright, so number 10 or 4, whatever, same thing, you can scratch off one of them. J of x equals 5 over 3 minus 2e to the x. And again, we got to find all three holes. Again, I'll try to speak less to give those who need some space the time and space to do that. I'll write more about the steps. So I always take a step 1. Not much here. Now I'm going to attack the holes. Always go with the holes first. Remember, holes talked about cancellations. Don't see much. Stop me with questions. Take VA next. You guys know the rules about how to find the vertical asymptote. Look back at the previous notes if you need some support on that. Okay, I got my holes up here. I got my vertical asymptote. Let me stop here before I go and do horizontal to see if there are any questions. Starting horizontal over on the right corner here. Got my horizontal asymptote up here. Those who are already there can check. Those who might have some uncertainty, please ask the questions. But now remember, you're not done, because we've only checked the positive side. Gotta check negative side now. There was a question before if those will always be the same. Here you'll get your answer that no, they will not always be the same. Before I do that, I want to see though, are there any questions on this part before I try the negative infinity side? Okay. And now we found a different horizontal asymptote on the negative side. Questions on this? If you got this, please go ahead and do number 5.